Suresh here, your Games Academy faculty for Biochemistry. Hope all of you are doing good and you have successfully given INI-CET May 2023. So based on the questions that student has been recalled and posted across social media, I have tried to collect all those questions and to do this recall session. Hope it will be fruitful to the next time attempters. So, to talk about the first question that has been asked, which of the following deficiencies can cause xanthinuria? Xanthinuria is a tryptophan metabolism defect, okay? And xanthinuria, and whatever the options they have given, here the options have been given manganese, magnesium, molybdenum, and zinc. Manganese, molybdenum, and zinc. So here they didn't ask directly the enzyme, but the cofactor which will be cofactor which will be helping the enzyme which is useful in conversion of xanthin to other product. The main key part here is xanthin oxidase. Xanthin oxidase is dependent on what to say is mainly on B6 and sometimes cofactor whatever it is like manganese, magnesium, molybdenum, zinc. So the correct option will be molybdenum. Here two types of xanthinuria you can say, type 1 and type 2. Type 1 is mainly because of the defect of the enzyme xanthin oxidase, whereas type 2 xanthinuria is because of the absence of the cofactor molybdenum. So molybdenum absence causes xanthinuria type 2, and because of this recurrent renal stones you can see. So the correct option, if these are the options, the correct option will be molybdenum. If vitamins they would have asked, I can definitely go for PLP, pyridoxal phosphate B6, the coenzyme of B6, that is pyridoxal phosphate. Yeah. The next question, this is again an easy one. We have already discussed a number of times in our previous like one-liners and previous year questions, image-based questions, glycogen storage disorders. So, which enzyme deficiency causes Pompe's disease? Here, options they have given: lysosomal alpha glucosidase, option B, muscle glycogen phosphorylase, option C, glucose 6-phosphatase, option D, beta glucosidase. So Pompe's disease is one of the characteristic disease related to lysosomes. So Pompe's is a lysosomal disorder. Remember that is a key point. Main disease that related to lysosomes of glycogen. So all of the glycogen storage diseases if you see, this is a lysosomal based. So key itself is in the answer, lysosomal alpha glucosidase, otherwise acid maltase. So because this alpha glucosidase is present in lysosomes, otherwise known as acid maltase, right? So the enzyme deficiency can cause Pompe's disease. Option A is the correct one. And muscle glycogen phosphorylase, it is related to what? Muscle glycogen phosphorylase, M for M, McArdle's disease. Okay. And glucose 6-phosphatase is deficient in von Wricht's disease. And beta glucosidase, it is outer glycogen storage disease. It is Gaucher's disease, lipid storage disorder, beta glucosidase. Another question, calculate anion gap. So anion gap is number of anions equal to number of anions minus total number of anions minus total number of cations. So which will give you the anion gap. Here sodium is a cation, potassium is a sodium, potassium which are having positive charge 145 is a millimoles of equivalent per liter, and potassium 4 millimoles equivalent per liter. Chloride and SiO3 bicarbonate, they are negative in charge, so 90 15. So you have to calculate, so positive charge molecules and negative charge molecules, 145 plus 4, that is 149, and if you calculate both plus the Cl chloride and bicarbonate, 90 15 105, you have to minus 105 from 149. So whatever the actual value you are getting, that is the answer. So the options that have been provided and the postings, these are the things. So the correct option will be 44. Sometimes there is a thing that you have to miss potassium. So it is okay. Sometimes if you didn't mention the potassium in the count also, that is okay, which is nearest to value. If you didn't take the count of this one, so 35 might be the correct answer, which is near to the 40. Right. Yeah. So another question, true about iron deficiency anemia. So the question itself explains better that iron is deficient in this anemia. So anemia is because of iron deficiency, because iron is not available in the heme synthesis, the last step, ferrochelatase enzyme which works on it, incorporation of iron. So that is the reason RBCs are without iron, so leads to iron deficiency anemia. So what are the characteristic features they are given? So here the options like low iron, low ferritin, high total iron binding capacity, low transferrin saturation. So here low iron and low ferritin will stimulate, what to say, low iron gives a feedback in stimulation for the transferritin levels to increase. So which can be translated to ferritin. And low transferrin saturation, if you how to calculate. So here decrease in serum iron divided by increase in serum total binding capacity. So these are characteristics are true. Low, yes, in iron deficiency anemia you can observe low serum iron levels, low storage form of iron levels, and high total iron binding capacity because of low levels, and low transferrin saturation also you can observe. So all four options are correct. I didn't get the wrong option. The question might be true about iron deficiency anemia except, so that wrong option I didn't get it. So all the four features, whatever the given options are correct. Yeah. This question related to molecular biology. Template strand is 5 prime CG TTA TTTACTA3. So template strand, you should get in your mind whenever the question template strand, okay, transcribed by RNA polymerase, the sequence of new RNA will be how it is. So RNA will be transcribed in the template strand in 3 prime to 5 prime direction. So you have to reverse the template strand. So you have to read the template strand from 3 prime to 5 prime as new RNA will be produced in 5 prime to 3 prime direction. So you have to start denominating it from 3 prime end. So here A is there in template strand. So suppose usually codes for thymine, but in RNA there is no thymine, uracil is there. So wherever A comes, that is uracil. So first thing to start is AU. So here, as I said, new RNA will be transcribing from 5 prime to 3 prime. So option C, where it is U. So there itself you can easily make out U. Option C, you see here, it started with U. Adenine coding, adenine present in DNA is coding to uracil in the RNA. So option C directly it is whatever the thing is giving. So option A, B, which are not starting with the U. So if they want to confuse you, they would have given clearly they given the option. So option C is the correct answer. Thermic effect. What is thermic effect? Thermic effect is otherwise known as specific dynamic action of food. What do you mean by specific dynamic action? Specific dynamic action can be defined as amount of energy spent above basal metabolic rate. Because we, though however you eat, don't eat, there should be certain amount of energy to be spent on the fuel to get energy. Right? That is, there is a amount of energy that is known as basal metabolic rate at which they will be getting. But there are certain foods they require energy beyond the basal metabolic rate. Okay, that is known as specific dynamic action. Each food molecule is having its own specific dynamic action. So specific dynamic action for fats is intermediate and for carbohydrates is low because we need to spend less energy to get energy from carbohydrates. But fats we need to spend intermediate amount of energy. But for proteins we need to spend more than 30% of basal metabolic rate. Right. So thermic effect is highest for fats is false, highest for carbohydrates is again false, highest for proteins yes. Above 30% of BMR we need to spend energy to get from the protein molecules. And equal for all the fuels? No, it is also wrong. So the correct option is C, highest for proteins. So which is false about collagen? Again, which is false about collagen? If you see here, phenylalanine option A they given. Phenylalanine is the most abundant amino acid. Option B, it is a fibrillar protein. Option C, hydroxyproline. Okay, hydroxyproline and proline are present. Option D, cross-linkage formation uses vitamin C and copper. So I can say here collagen characteristics. If you see the characteristics of collagen, glycine is the most abundant amino acid you get in collagen. Every third amino acid if you see in collagen structure, that is glycine. So next to the glycine you can put X and Y. X it can be proline and Y it can be lysine. So hydroxyproline and hydroxylysine, hydroxylation reaction. All right. So option A, which is not correct statement. Phenylalanine is not common amino acid. Glycine is the commonest amino acid. Okay, so the option correct for this question, that is A. Okay, which is false, right? And the option, it is fibrillar. Yes, there are different types of collagens we have seen. Type 1, type 2, type 3, type 4, type 5, type 7, type 9. Right. So there are certain types of collagens which are fibrillar in position. Okay, like collagen type 1, type 3, type 4, type 5, type 7, type 9 are the fibrillar type collagens. Hydroxyproline and proline are present. Yes, proline and lysine undergo hydroxylations to form hydroxyproline. And cross-linkage formation, yes, we are all aware that collagen is a triple helical structure. Three helical structures will be there, which has to form a triple helix for the strong nature. This cross-linkage obviously helps by vitamin C and copper. So rest of the options are true except A, that is false. Next question. A mother, while kissing the child, finds the sweat of the child to be salty. Which of the following channel is affected? Options, they are given: sodium, chloride, potassium and iodine. So remember, the child sweat is salty. So here this is a clear-cut case of cystic fibrosis. So cystic fibrosis, what is the defect? There is a defect of CFTR, chloride functioning transport regulatory channels will be affected. CFTR gene is defect, so chloride channel will be blocked. So chloride is being produced in exocrine glands and excreted. So when it get excreted, it's supposed to get inside by the channel, chloride channel. As there is no reabsorption, what happens? Chloride along with it take the sodium, and sodium grabs the hydrogens. So altogether, what happens? There is increase in sodium chloride levels in the sweat. There is a thick mucus type of secretion in the sweat. So here the option is chloride channels. Otherwise, they would have specifically would have mentioned CFTR gene is the prompt answer. So chloride channels will be affected in cystic fibrosis. So that is the reason chloride is secreting along with the sodium as sodium chloride in the sweat. Yeah. Here the question, it is image based question again. A young boy with type 1 diabetes presents with unconsciousness. His urine is subjected to a test and the result is provided below. The test that is done is option A, Benedict's test, option B, Rothera's test, option C, Biuret test, option D, Faucher's test. So here, forget about the image and the options. First, you read the stem of the case. A young boy with type 1 diabetes. So type 1 diabetes means what? Insulin absence, absolute insulin absence, autoimmune disorder, type 1 disease, type 1 diabetes. The person doesn't have any insulin level. He's supposed to take the insulin. By chance, he would have missed taking of insulin dose. He will be hypoglycemic. So what happened? Because there will be high blood glucose levels, but cells are starving. So in that condition, what happens? If you see the pathophysiology of type 1 diabetes, if cells are starving for energy, so they don't have glucose to provide energy. So what they go for alternative metabolic pathways such as uh, lipolysis and ketone body production. Because of lipolysis, you will be getting most of acetyl CoA, and this acetyl CoA cannot be incorporated or accommodated in TCA cycle. So what happened? They diverted for other alternative pathways such as ketone body metabolism. If these ketone bodies are started producing, yes, they will be important to the brain to provide energy. But as the substantial increase in the level in the blood, they start excrete in the urine. At the same time, they start causing acidosis. Metabolic acidosis leads to again, it is a dangerous condition to brain as well. So in that condition, as ketone bodies will start excreting in the urine. So if abnormal constituents of urine, if you perform the practical, you might have in first year would have performed. So in that condition, reducing sugar along with the ketone bodies, diabetic ketoacidosis. But here, the person is diabetes at the same time ketone bodies, but glucose is not shown as a positive here. But there is a purple color ring, right? So Benedict's test is purely for reducing sugar. The person is diabetic, obviously the Benedict's test will be positive. But here they didn't show you the Benedict's test, but they show you the Rothera's test. Rothera's test, when ketone bodies are there in the urine, It reacts with the Ruther's reagent to show purple colored ring. So that's what in the image we got. Biochar test, if you see, that is confirmatory test for proteins, and Poucher's test is for any liver disorders like hepatitis, carcinoma. So in that condition, what happens? Bile pigments. If bile pigments start excreting, if there is a, because bile pigments as such directly they will not be excreted in the urine, they will be conjugated and will be excreted. So in case of Poucher's, these unprocessed bile pigments will be appeared in the urine, which will give positive to the Poucher's test. So the correct option here, that is Rothera's test. Remember, for ketone bodies, the confirmatory test is Rothera's test. Yeah. Another question. Barth syndrome presents with heart failure, deficiency of which of the following structure in mitochondria membrane is the cause of the syndrome. So here Barth syndrome present with heart failure, right? So deficiency of which of the following structure in mitochondrial membrane is the cause of this syndrome. Options they have given: lysolecithin, plasmalogen, lecithin, and cardiolipin. Right. So these are the options. Lysolecithin, it is what to say? It is lysolecithin is a degradative product of phospholipid because it is short of one fatty acid. Plasmalogen, you can see in the anticoagulants. Lecithin is a lung surfactant, dipalmityl acetylcholine, dipalmityl lecithin. Cardiolipin is the main thing in the Barth syndrome. So here the gene defect is tafagin gene. Okay, in Barth syndrome, the main gene that deficient is tafagin gene. Because of the deficiency of the gene, there is no coding of a protein related to the enzyme, that is acyl transferase in the inner mitochondrial membrane. This acyl transferase in inner mitochondrial membrane is responsible for synthesis of cardiolipin. This cardiolipin present in red muscle fibers of the heart. So as this cardiolipin is not synthesized, there is a cardiomegaly, cardiomyopathy and neutropenia are the characteristic features. So Barth syndrome is clear-cut indicator for deficiency of cardiolipin in the mitochondrial membrane. Again, one of the favorite question related to oxyhemoglobin. The curve has been showed here, the graph. Oxyhemoglobin dissociation curve of a person with carbon monoxide poisoning. So the above curve, that is normal oxygen dissociation curve, okay, and below one, that is a carbon monoxide dissociation curve. So here this carbon monoxide poisoning, the graphs they have been provided. So what is the type of hypoxia? The question has been asked. Hypoxic hypoxia, anemic hypoxia, stagnant hypoxia, histotoxic hypoxia. Here I'll tell you oxyhemoglobin and carbon monoxide hemoglobin. So if you keep oxygen one side and carbon monoxide one side in front of the hemoglobin, hemoglobin will choose to bind to carbon monoxide because the affinity of hemoglobin towards the carbon monoxide is high compared to the oxygen. So that is the reason whenever there is a carbon monoxide poisoning, all the hemoglobins leave the oxygen and start combining or binding with the carbon monoxide. So what happened, because of this oxygen carrying capacity of the hemoglobin decreases and RBC cells will be like fragile. So that is the reason here carbon monoxide poisoning, as the curve shifts towards the right side, you can make out anemic hypoxia. Here it is related to hemoglobin, so it is anemic hypoxia. Carbon monoxide poisoning, oxygen dissociation curve, there is a decrease towards right side because of anemic hypoxia. Why not hypoxic hypoxia? In hypoxic hypoxia, okay, the arteriolar pressure is low because it didn't reach. If you see the arteriolar pressure, it's supposed to reach 100 millimoles of mercury, but it didn't reach. Here arterial pressure is low. Okay, so that is the ruled out option. How about stagnant hypoxia? In stagnant hypoxia, arterial venular PPO2, partial pressure of oxygen, arterial venular partial pressure of oxygen, which is supposed to be 50. Here AB pressure is high. So if it is 50, then I can make out stagnant hypoxia. But here that that concentration is high. And again, instead of hypoxia also zero. You can make out with the arteriolar and ventricular partial pressure of oxygen. You can calculate that. So instead of hypoxia is a ruled out option. So correct option is anemic hypoxia. Yeah. Again, molecular biology based question. SRY gene is located in. That means what? SRY gene, how you define? Sex determining region of Y chromosome. SRY is nothing but sex determining region of Y chromosome. Sex determining region of Y chromosome. Right. So already learned that chromosome short arm and long arm. So where this SRY gene is located in short arm or long arm of which chromosome? So already SRY is related to Y chromosome. So X ruled out option. Okay. So option A long arm of chromosome X no. B long arm of chromosome Y no. Short arm of chromosome Y yes. This is the correct option. SRY gene is located in short arm of chromosome Y. Okay. And short arm of chromosome X is also ruled out option. Because SRY gene what it will do? SRY gene it codes for a protein which acts on the medulla to synthesize primitive gonads, that is testis. Massive blood transfusion causes all of the following except. So massive blood transfusion, what happens? Massive blood transfusion causes. So as red blood cells are storing, so what happens? They are all deprived of glucose. So options what they have given: hypokalemia, hypocalcemia, hypomagnesemia, alkalosis, except they said. So here, as glucose levels are dropped, sodium potassium there is no energy, so sodium potassium pump will not be activated, right? So will not be activated. So because of that, that sodium pump, I mean sodium to go out and potassium to get in, that will be not happening, right? So here what happened? Hypokalemia is the prominent answer I can say. Hypocalcemia will never, hypomagnesemia also you can never, and alkalosis also. Why? Because because there is a hypercalcemia, because there is a chelative agents, so which can relates to leads to hypercalcemia, and hypomagnesemia again it is a chelative agent, and alkalosis if you see, uh, what to say, metabolic alkalosis. Why? Because the blood has been stored in a citrate, the preservative, that citrate. So this citrate will be incorporated into the TCS cycle and it produces more amount of what to say, carbon dioxide, and this carbon dioxide is involved in making of bicarbonates. So it leads to alkalosis. High in levels of bicarbonates gives you condition alkalosis. So alkalosis is possible. Hypomagnesemia also, because magnesium there will be chelated, so it will be low levels of this one. And hypocalcemia is also yes, both calcium and magnesium are chelated. And hypokalemia, there is no such thing in hypokalemia. You can see only sodium, because why? Because sodium and potassium they will be in normal only, because sodium potassium pump will not be working as glucose levels are low. So right option is A. Hypokalemia you cannot see massive blood transfusion. Otherwise you can see hypocalcemia, hypomagnesemia and alkalosis. Again one more question related to acid base balance. Severe vomiting leads to options: hypokalemia, hypochloremia, metabolic alkalosis and respiratory alkalosis. So here I can say hypochloremia. Why? Because in vomiting you are just emptying the gastric secretions. Gastric secretions mainly made up of chlorides, right? So because of this I can say go option hypochloremia. And again you to say it is all because of what? It is all because of so hypochloremia leads to dehydration, and dehydration there is a decrease in arteriorenal pressure, so leads to secondary hypoaldosteronism. Secondary hypoaldosteronism. So what the secondary hypoaldosteronism? This secondary hypoaldosteronism, sodium reabsorption will be there, so and potassium excretion will be more along with the hydrogen excretion. So it leads to metabolic alkalosis. Simplest question again. Next to the Totras test. Liver can't utilize ketone bodies because of lack of. liver cannot utilize ketone bodies, because we have already learned that ketone bodies are produced in our body at liver. Okay, liver are the sole source for production of ketone bodies. Though liver can produce ketone bodies, it cannot utilize those ketone bodies. Why? Because they lack the enzyme thiophorase. If you see the options thiolase, thiophorase, thioesterase, Fmge cosynthetase, option B is the correct one, because liver cells lacks the enzyme thiophorase. That is the reason liver cannot able to or couldn't able to utilize those ketone bodies. Right. Thiolase, it is not related to ketone body metabolism. Thioesterase again, thiolase is breakdown of acetyl CoA in case of lipolysis. Thioesterase again, and Hmg CoA synthase related to cholesterol synthesis. Option B is the correct one. So the hormone which acts through JAK-STAT pathway, the hormone which acts, there are certain all type of hormones. They have their own specific unified pathways to convey their message into the cell. So JAK-STAT is one of the pathway to. So here which one? So here JAK-STAT pathway. Calcitonin, leptin, aldosterone, vasopressin. So calcitonin, which will not be work because GQGS pathway, calcitonin will be acting, and leptin, yes, leptin is the hormone present in the adipocytes, which definitely acts through JAK-STAT pathway. And leptin, what is the role here? So it is having a key role on satiety center of the brain. So whenever you are trying to eat more food, this leptin releases from the adipocytes and try to control on the satiety center of the medulla to stop eating. So that's why it balances your diet and keeps your weight in the controlled way. And if you see aldosterone and vasopressin, vasopressin, if you make out V1 and V2, V1 is for more water reabsorption, V2 is for constriction of arteries. Yeah. Cholestasis is mediated through defect of which of the following proteins? Cholestasis is mediated through defect of which of the following proteins? So cholestasis means what? Dublin-Johnson syndrome, Dublin-Johnson syndrome, or black liver disease, or black liver disease. So here the black liver disease, why? Because there are certain type of transporters around the liver cells to transport unconjugated bilirubin to liver, and once these bilirubins are processed unconjugated to conjugated, then they are supposed to enter into the intestine through hepatobiliary caniculi. So here there is also a transporter located in the hepatobiliary caniculi. So that is which one? So the transporter coded by which of the gene are the proteins, transporter proteins? That's the question. So OAT1 B1 will be useful in transport of unconjugated bilirubin into the liver. Okay, and MRP3 is main thing to secrete or release processed bilirubin into the circulation, and ABCA1 is related to the Tanger's disease, it's related to lipid metabolism. And MRP2 is the protein which present in the hepatobiliary caniculi, which is responsible for the secretion of processed bilirubin or uh, detoxified products or drugs into the intestine for the excretion. So that is a main thing. So here the correct option is MRP2. What is the full form of MRP2? Multi-drug resistant protein 2. This is a transporter or translocator present on the hepatobiliary caniculi to release this. So because of absence of this MRP2, the processed things will start depositing in the liver cells and causes conjugated bilirubinemia or Dublin-Johnson syndrome, otherwise known as black liver disease. So that's all about the questions we come across so far. If in case if I am getting the more questions and with the prompt options, then I will definitely doing the elaborated recall session with the details. Hope the session is fruitful and hope you have cross-checked your answers with the questions. So don't worry, if it goes wrong, it is like experience. There is always a next chance, and all the best for your upcoming competitive exams. Thank you.